Hi everyone, we're going to go over the notes for rationalizing the denominator, but we're going to start again. Simplifying radicals you can do, multiplying radicals we can do, adding radicals we can do, dividing radicals you don't really divide. What you do is you rationalize the denominator to eliminate radicals in the denominator. So our first example here is 2 radical 5. So if you have 2 radical 5, I'm going to go back to that screen in just a second. I want to go all the way back. We're going to eventually get to the point where you can rationalize denominators like with two different terms. All right. So, and we're also going to be able to do ones that are big fractions. So fractions that cover the entire thing. So let's start again. So here's your original problem. Rationalizing means never leaving a radical in the denominator, but you have to multiply the top and the bottom by that bottom radical. And that will eliminate the radical in the bottom by making square root of 5 times square root of 5, which is square root of 25, which is 5. Now the top comes along with it because whatever you do to the bottom, you have to do to the top. There's nothing to simplify on the top. You just simply multiply 2 radical 5. Next, let's do another example. What happens now when the fraction covers both? If it covers both, you have to reduce first, if you can, and then you split up the square root. Watch what happens when you split up the square root. You now only have a 2 in the top and a square root of 3 in the bottom. What if the bottom became square root of 9? You'd be done. You wouldn't even have to rationalize. So it's always good to simplify when you can. Same rules apply. Multiply the top and the bottom by the square root of 3 because it's the denominator. And that's how far you get it, all the way to 2 radical 3 over 3. Now what happens when you have a huge term or a bigger term, a two-term polynomial, or a term that has a plus sign or a minus sign? You now have to, I asked the class, and one thing people always say is same rule, try the same rule. If you try the same rule, does it eliminate the radical in the denominator? And the answer is no, because your denominator now becomes 10 plus 2 radicals 20 square root of 21. So we have to come up with a new way of doing this, and the book calls it the conjugate. So that's when you multiply the top and the bottom by not the bottom, but the bottom with an inverse sign in the middle. And if you do that, it should, if we did it right, eliminate our denominator. So we now have, when we FOIL it out, we get 7 minus square root of 21 plus the square root of 21 minus 3. And they do cancel out, leaving us with a 4 in the bottom. That's how you rationalize denominators.